गुड इवनिंग सभी को। नमस्कार, स्वागत है आपका हमारे इस प्लेटफॉर्म पर जिसका नाम है वन मार्क्स सॉल्यूशन। और जैसा कि आप सभी जानते हैं कि लगातार हमारे साथ डिफरेंट सब्जेक्ट्स के डिफरेंट चैप्टर्स के 1 मार्क्स के जो क्वेश्चन होते हैं, फिल इन द ब्लैंक्स होते हैं, मैच द फॉलोइंग क्वेश्चंस होते हैं, जो 1 मार्क्स के जितने भी क्वेश्चंस होते हैं उनको डिस्कस करने के लिए हमारे साथ यहाँ पे एक एक्सपर्ट आते हैं जो कि अपने प्रेजेंटेशन के थ्रू, अपने एक्सप्लेनेशन के थ्रू आपके साथ 1 मार्क्स के जो क्वेश्चन होते हैं उनको डिस्कस करते हैं। तो उसी सीरीज में आज जो सेशन होने वाला है वो क्लास 11th के लिए केमिस्ट्री सब्जेक्ट है। क्लास 11th के लिए टॉपिक है स्टेट ऑफ मैटर, और जिसके लिए आज का जो सेशन है वो बहुत ही ज़्यादा अच्छा होने वाला है, क्योंकि जो आज हमारे साथ रिसोर्स पर्सन है वो बहुत ही वेल एक्सपीरियंस्ड हैं। तो मैं उनका मैम का स्वागत करना चाहती हूँ। मोस्ट वेलकम मैम आपका इस स्टूडियो में ऑन बिहाफ ऑफ आवर 1 मार्क टीम एंड बिहाफ ऑफ व्यूअर्स आपका स्वागत करती हूँ। मैम का मैं थोड़ा सा इंट्रोडक्शन दे दूँ। मैम रिटायर्ड हैं। मैम का नाम है रीता मोहंती और मैम रिटायर्ड हैं फ्रॉम केंद्रीय विद्यालय संगठन। काफ़ी लंबा एक्सपीरियंस है मैम का। डेडिकेशन और अफेक्शन इतना है सब्जेक्ट के प्रति कि अभी भी मैम बच्चों से पूरी तरीके से जुड़े हुए हैं, अपने सब्जेक्ट से जुड़े हुए हैं कि आप लोग के सामने वो अपना प्रेजेंटेशन लेके आए केमिस्ट्री का। तो आप लगातार इस पे बने रहिए, प्रेजेंटेशन आप लगातार देखते रहिए। लास्ट में मैं फीडबैक फॉर्म एक शेयर करूंगी लाइव कमेंट बॉक्स में, जिससे कि सेशन से ही रिलेटेड उसमें अगर आप 40% मार्क्स लेके आते हैं तो आप एक अटेंडेंस सर्टिफिकेट भी आपके मेल पे इशू होगा। तो मेल आईडी उस पर करेक्ट डालिए। और हमारे जो कंटेंट पार्टनर हैं वो 1 क्वेश्चन एवरी टाइम है, जिनको कि आप इंस्टाग्राम पे भी फॉलो कर सकते हैं, जो कि एप्टीट्यूड टेस्ट के लिए जाने जाते हैं। और आप हमारा भी 1 मार्क सॉल्यूशन का पेज भी इंस्टाग्राम पे फॉलो कर लीजिए और चैनल को सब्सक्राइब कर दीजिए, जिससे कि आपको जो भी अपकमिंग वेबिनार्स रहेंगे उनके अपडेट्स आपको मिलते रहेंगे। और प्ले लिस्ट में जाके आपको जो इससे भी पहले सेशंस हुए हैं और भी चैप्टर से रिलेटेड, सब्जेक्ट से रिलेटेड, वो भी आपको मिल जाएंगे। तो मैं ज़्यादा टाइम नहीं लेते हुए मैम को अभी हैंड ओवर करती हूँ। मैम प्लीज।
Thank you, Priyanka. Thank you so much for giving me this opportunity and this platform for sharing my experience and my knowledge with the students and my staff members and colleagues. So, good afternoon, everybody. Today I am going to have a session on a chapter from class 11. The chapter is States of Matter. It's a very interesting chapter, and right from lower classes, we know something or the other about the states of matter. Normally, we know there are 3 states of matter like solid, liquid, and gas. And in different classes, we have already read about that difference between solids, liquids, and gases. Now, as you all must be knowing, there is a 4th state of matter known as plasma state. Of course, we are not going to discuss in detail about this. This is not included in our chapter. And in this chapter, this year, especially due to the pandemic, certain portions have been reduced. Liquids, kinetic theory, and many other portions have been deleted from this chapter. We will be just touching it for your information. And since it is based on 1 mark solution, so I have tried my level best to include all types of 1 mark questions, which will make you aware about the chapter, and you will be all nicely acquainted about the different your description or definition or different words included in this. The different type of questions that I have included is your first is MCQ, multiple choice, which gives us a better awareness or better platform to understand the question as well as the answer. Then some assertion and reasoning. I found from my experience of copy correction that students normally make mistakes in assertion and reasoning questions, because It's a new thing rather. And for class 11 students, definitely a completely new thing. So for that, I try to include few and I will explain how to answer it. In addition to that, just like in lower classes, you are doing matching type. So the intention of all this is to give you more and more idea about the same question. The portion is not too much, but when you get different types and different pattern of questions of the same answer, you are well acquainted with it. To start with, when we think about different states, that is solid, liquid and gas, the major difference is that the intermolecular forces of attraction or the intermolecular distance. We all know that solids have strongest molecular force of attraction, liquids have less than that, and gases are having still less than that. So in all these cases, there are not only forces of attraction operate, there is also some force of repulsion is there, and thermal interaction is also there. The balance of the three types of these interactions describe the state of a matter. Whether it should be in solid state, liquid state or gaseous state, that is decided by the three interactions, that is intermolecular force of attraction or molecular interaction and thermal energy. Let us start with the questions now. Dipole-dipole forces act between the molecules possessing permanent dipole. Ends of dipoles possess partial charges. So before going to the question, let me introduce a little bit about the dipole-dipole forces. In lower classes, we have read about ionic compound or covalent compound. In ionic compound, there is a force of attraction between the ions, which is your electrostatic force of attraction. But the dipole-dipole force is a force that exists between the molecules possessing permanent dipole. Okay, and so this is a stronger force. Of course, it is stronger than the force that operates between non-polar molecules, that is London force, but it is weaker than ionic bond. So the question here is the partial charges, whether it is more than 1 unit electronic charge, equal to unit electronic charge, less than unit electronic charge, or double the unit electronic charge. The first thing is, since it is partial charge written, there are two options possible. One is more than unit or less than unit. So it is here less than unit electronic charge. Answer is C, because it is a partial charge which is not equal to +1 or -1. Rather, it is represented as delta plus or delta minus. So they possess partial charges and they are less than the unit electronic charge. This one is a question of graph. We normally get graph definitely for answering, and from the graph we can see it is a graph between volume versus temperature. And if a graph exists between volume and temperature, it's the relationship between volume and temperature, and we can see that the graphs are straight lines and that represent P1, P2, P3, P4, which is pressure. And such graphs, for your information, let me tell you, since they are measured at a constant pressure, such graphs are called as isobars. They are called as isobars. And you can see that at any one pressure remaining constant, the graph is drawn between volume and temperature. And the relation, we know that with increase in pressure, volume decreases. As pressure increases, volume decreases. This is as per your Boyle's law. So definitely P4, which is the last one, that will have the highest pressure because volume is more than, and then it's P3, then P2, then P1. So the question here is, plots at different values of pressure are shown. Which order of pressure is correct? Definitely it is C. Answer is C. P1 is less than P2, less than P3, less than P4, because with increase in pressure, volume decreases. So that is the relationship, and the law is known as Boyle's law. So here it is called isobars, and pressure, with increase in pressure, volume decreases according to Boyle's law. I think I am clear about it, and the students will try to remember it from the graph along with the law, because these laws are important to use it in different numericals. We can solve many numericals if you remember the formula only. For remembering the formula, graph is more essential. Here is a question related with a easy numerical. We normally get such easy numericals as 1 mark questions also. The pressure of a 1:4 mixture of dihydrogen and dioxygen enclosed in a vessel, and the total pressure is 1 atmosphere. The total pressure is 1 atmosphere. What would be the partial pressure of dioxygen? In a mixture of non-reacting gases, hydrogen and oxygen are enclosed, so they are non-reacting gases. So the total pressure will be the sum of the partial pressure of oxygen and partial pressure of hydrogen. And here the ratio between hydrogen and oxygen is given. When we know the ratio between hydrogen and oxygen, we can find out the number of moles it is given, from which can be obtained the mole fraction of hydrogen and oxygen. Because to calculate the partial pressure from Dalton's law, to calculate it, partial pressure of oxygen will be mole fraction of oxygen multiplied by total pressure. Total pressure is already given as 1 atmosphere. To find out mole fraction of oxygen, mole fraction is number of moles of oxygen divided by total number of moles. So it is easy to calculate, not a difficult numerical, because number of moles of oxygen is 4. Total number of moles is 1 plus 4, 5. So 4 by 5 into 1. 4 by 5 is 0.8 into 1. That is 0.8 into 10 to the power 4 atmosphere. That will be, the answer is C, 10 to the power 4 Newton per meter square. Newton per meter square. This is the solution given here also. How we calculate the mole fraction? 1 divided by 1 plus 4, that is 0.8. So partial pressure of oxygen is 0.8 atmosphere, or if atmosphere you convert into Newton per meter square, it is 8 into 10 to the power 4 Newton per meter square. Because question just to confuse you is given as 0.8 into 10 to the power 5 atmosphere, which is wrong. It is 8 into 10 to the power 4 Newton per meter square. Gases possess characteristic critical temperature. What is a critical temperature? Critical temperature is the temperature above which it exists as gas and below which it will be in the liquid form. Above which no liquid is found and below which it exists as liquid. And how to find out that temperature, that critical temperature? Because when gases do exist, we want to liquefy, we have to increase the pressure, at the same time decrease the temperature. So let us suppose here the data for the critical temperature is given. Hydrogen, helium, oxygen, nitrogen data are given. How to calculate or how to know that which one will liquefy first and which one will liquefy after that? Let us suppose the gases are at 180 Kelvin temperature. 180 Kelvin temperature. We are trying to decrease the temperature from 180 when we are coming below 180, 170, 160, 155, till that it is in gaseous state. When it becomes 154.3, oxygen starts liquefying, but nitrogen cannot, because nitrogen requires 126. So above 126 up to 154.3, nitrogen will be in gaseous state. It cannot liquefy. When it comes to 126, nitrogen starts liquefying. Then again we are going below. When it comes to 33.2, then hydrogen will start liquefying, then helium. That is why the correct order will be option D. Oxygen, nitrogen, hydrogen, and then helium. This is the definition for your better information, or you can read it afterwards also. Temperature above which gas cannot be liquefied. So higher the critical temperature, easier it is to be liquefied. This is atmospheric pressures of different cities. For Simla, Delhi, Bangalore and Mumbai, the pressure is given in Newton per meter square. Atmospheric pressure, and the question that asks is where the liquid will boil fast. So the relationship between boiling point and atmospheric pressure. The temperature at which atmospheric pressure becomes equal to the internal pressure or vapor pressure, the liquid starts boiling. Because whenever we start boiling, we are heating some liquid, we just continue heating by increasing the temperature, and by increasing the temperature, what happens that the pressure is developed inside the container, and when this vapor pressure becomes equal to the atmospheric pressure, the liquid will start boiling. So wherever the vapor pressure is low, liquid will start boiling first. That is why the question here is, or the answer will be, Simla will boil first. Answer is A, because it is having 1.01. You can find that in all the cases 10 to the power 5 is there. First thing you have to find out, in all the cases 10 to the power 5 is there. But one is 1.01, 1.02, 1.2, which means 1.20 and 1.21. So automatically Simla having 1.01 in 10 to the power 5 Newton per meter square will boil fast. The liquid will boil fast there. This is the answer to it. Vapor pressure of the liquid equal to external pressure, then the liquid starts boiling. Here is a graph plotted between PV versus P. PV versus P. There are so many types of graphs you will be coming across. P versus V, P versus 1 by V, PV versus P. So here there is a graph which curve represents the curve of ideal gas. Ideal gas equation is your PV is constant. PV is constant because with increase in pressure, volume decreases. So as soon as the pressure will increase, volume will decrease. So for ideal gas, it should always, since it is a product, it should always remain constant. So here the answer is graph B. Answer is A. Graph will be a straight line parallel to the pressure axis. Increase in kinetic energy can overcome intermolecular forces of attraction. How will the viscosity of liquid be affected by the increase in temperature? Increase in kinetic energy, with increase in kinetic energy, motion, because kinetic energy is energy of motion. So motion increases means intermolecular forces of attraction decreases, and viscosity is the resistance to flow of liquid. It is the resistance of flow of liquid. So what will happen with increase in temperature? With this much clue, you can now answer also that the viscosity of the liquid will decrease with increase in temperature, because liquid will start moving apart, or intermolecular forces of attraction will decrease. So it will be decreasing. It is a resistance to flow. This is due to again internal friction between layers of fluids. So this liquid viscosity decreases as the temperature rises. and molecules have high kinetic energy and they can overcome the intermolecular forces of attraction, which was just objecting it to flow. That force of attraction will decrease, so viscosity will decrease. Which of the following statements is wrong for gases? Most of the statement about gases you already know. Gases do not have a definite shape and volume, correct? Volume of the gas is equal to the volume of the container confined in the gas. Because if you have a drop of perfume also, you get the smell inside the whole room because it occupies. Confined gas exerts uniform pressure on the walls of the container in all directions. That is also correct. Mass of the gas cannot be determined by weighing a container in which it is enclosed. This is wrong because mass of the gas we can only measure by weighing a container containing gas and then only the weight of the container. If you subtract, then we get it. So D is the correct answer. Mass of the gas will be equal to mass of the container plus gas minus mass of the container alone. Non-reacting gases have a tendency to mix with each other. This property is known as non-reacting gases. Some gases react with each other, but the gases which do not react, they mix with each other. This property is known as diffusion. So answer is A. Intermixing of gases is known as diffusion. Which of the following mixture of gases does not obey Dalton's law of partial pressure? It is just a little improvised of the previous question. In the previous question, we have discussed about non-reacting gases. This also is an extension of that. Dalton's law is applicable to non-reacting gases. So let us see in the options which two gases are reacting, because which does not obey, that means they are reacting gases. Oxygen and carbon dioxide, very sure that they do not react because they coexist in atmosphere also. Nitrogen and oxygen do not react. Chlorine and oxygen do not react. But ammonia and HCl, they react to form NH4Cl. So answer is option D. Is applicable to non-reacting gases. Ammonia and HCl react to form ammonium chloride. This is a question of relation between density and temperature. Density of two gases are in the ratio of 1:2. Their temperatures are in the ratio of 2:1. Then the ratio of their respective pressures. We know a little bit about the relationship between pressure and volume. In your Boyle's law, pressure is inversely proportional to volume. If it is inversely proportional to volume, then it is directly proportional to density. P is inversely proportional to V, or P is directly proportional to density. And pressure is also proportional to proportional to your temperature. So here the answer is A, which is 1:1. Because density is in the ratio of 1:2, temperature is in the ratio of 2:1. So answer is A. Look at here. P1 by P2 is equal to D1 T1 by D2 T2. D1 T1 by D2 T2. So it is 1/2 into 2/1. So answer is 1:1. Gas equation PV is equal to nRT is obeyed by, we know this is for ideal gases, but often students confuse when the options are, is it applicable to only isothermal process, or it is to only adiabatic process, or both isothermal and adiabatic, and both none of this. Because isothermal and adiabatic you will be reading in your thermodynamics chapter. Just after this chapter you will be reading about it. But This gas equation is applicable to ideal gas equation, which is applicable for both isothermal and adiabatic process. So the answer is C, following isothermal or adiabatic process. Here is a graph. The question is, which law is applicable here? Here is a graph between volume and temperature in degrees Celsius. And one more important thing, you can see that if it is in degrees Celsius, the point of intersection which shows the 0 degree Celsius, the graph extends to the left of it, that means negative of it. So this is the equation of Charles' law, or the answer is B. Volume is proportional to temperature at constant pressure. Here is a simple numerical, just to keep you acquainted about it. 4.4 gram of a gas at STP occupies a volume of 2.24 liter. The gas can be, at STP, 1 mole of gas occupies 22.4 liters. 1 mole of gas occupies 22.4 liter. So when it is given that 2.24 liter, 4.4 gram of the gas occupies 2.24 liter. So 22.4 liter of gas can be occupied by 44 gram of the gas. So we have to find out from the option which gas has the molar mass equal to 44 gram. Oxygen 32, carbon monoxide 16 plus 12, 28, NO2 no, carbon dioxide 12 plus 32 is 44. So option is D. See, 44 gram occupies 22.4 liter. So molecular mass occupies 22.4 liter at STP. When the product of pressure and volume, that is PV, is plotted against P for a given amount of the gas, the line obtained is a similar question we have answered in the previous questions. The same question can be asked in a different manner. So here it is PV versus P. There it was PV versus B, where it is whether it is parallel to x-axis, parallel to y-axis, linear with positive slope, or linear with negative slope. The answer is A. It is parallel to x-axis at constant temperature. Air at sea level is dense. Dense means density is more. If density is more, volume will be less, because density is mass per volume. So if something is more dense, its volume is less. If volume is less, pressure is more, because pressure and volume are inversely proportional, and that is the law of Boyle's law. So air at sea level is dense. It's a practical application of Boyle's law. Answer is A. So at sea level it is dense, higher level it becomes less dense, or atmospheric pressure decreases as we go up and down. This is, so the Boyle's law can also be written as, or the relation can also be represented as, density is directly proportional to pressure, or it is MP by RT. So at sea level pressure is more, hence density of air is more. Equal volume of all gases. You may be asked about the definition. Previously it was asked that way. Now the question is more student friendly. So rather the definition is given, or the law is given, and which law, which rather gives you more away from the rote memory. You need not memorize the law and all, but from answering such multiple choice questions, you remember it better and you understand it also. Equal volume of all gases at the same temperature and pressure contain equal number of particles. This statement is a direct consequence of perfect gas law, Avogadro's law, Charles' law, Boyle's law. While answering such questions, you can go through or you can try to remember what is Boyle's law. It's a relationship between pressure and volume, temperature remaining constant. Charles' law, again the other way. Then what is perfect gas law? So it is Avogadro's law. The answer is B. Same number of particles will also be same, or number of moles remaining same. The value of R. Value of R is important these days because now the new norms of CBSE says that these standards or quantities values will not be given in the question paper. So you have to remember it. It is given in different way. That is little bit confusing. So better to understand it. It is 8.315 into 10 to the power 7. Into 10 to the power 7. But the answer is B, 8.314, which is 315 given. Joules per Kelvin mole. Per Kelvin mole. If it is joules per Kelvin mole, then it is 8.315. Compressibility factor for hydrogen and helium. What is compressibility factor? For ideal gas equation, we know that PV is equal to nRT. And for an ideal gas, PV by nRT is equal to 1. PV by nRT is equal to 1 is ideal gas equation, and this PV by nRT is known as the compressibility factor. But for hydrogen and helium, it is usually greater than 1. So answer is A. Since Z is more than 1, because PV is greater than nRT. The density of two gases are in the ratio of 1:16. The ratio of their rates of diffusion. Density is given, rate of diffusion. A rate of diffusion is proportional to square root of their density. Square root of their density. So answer is B, inversely proportional to their square root of density. So R1 by R2 is square D2 by D1. Density of the second by density of the first gas. So it is 16:1, which is equals to 4:1. Gas deviates from ideal gas nature because once we are having ideal gas equation, we know that ideal gas equation is not applicable to all the gases. Rather, real gases do deviate from ideal gas or ideal gas behavior. And what is the reason for that? Because the certain conditions that we accept, that the volume of the gases are negligible, that we take, and there is no force of attraction between volumes. So this is applicable only when they are far apart from each other. But when they are closer to each other, volume do have some value, or number of molecules are more than n number of volume will have some value. At the same time, there will be some attraction. So because molecules attract each other, that is why gas deviate, but we consider that gases have very less force of attraction and taken it as zero force of attraction. So the option is B. Intermolecular attractions are appreciable at high pressure and low temperature. So the ideal gas deviates from ideal behavior. The compressibility factor for an ideal gas. We have just read that compressibility factor for hydrogen and helium is greater than 1. At that point, I told you that for ideal gas, it is 1. So answer is B. PV is equal to nRT, or Z, which is the ratio of PV and nRT is equal to 1. A gas will approach ideal behavior. Since we have, in the previous question, we have already discussed about under which condition it will behave ideally. The options here are low temperature, low pressure, low temperature, high pressure, high temperature, low pressure, high temperature and high pressure. So the option is C, that is high temperature and low pressure. Low pressure means they are apart from each other. Low pressure means volume is more, so they are apart from each other, and high temperature, that is why under that condition it will behave ideally. At low pressure and high temperature, the larger the volume, less is the interaction, higher the temperature, more is the kinetic energy, and less is the interaction between the molecules. An ideal gas will have maximum density. It will have maximum density. Again, density is related to pressure because pressure is directly proportional to density because it is inversely proportional to volume. So here the options are pressure 0.5 atmosphere, temperature 600 Kelvin, pressure 2 atmosphere, temperature 150 Kelvin, pressure 1 atmosphere, temperature 300 Kelvin, pressure 1 atmosphere and temperature 500 Kelvin. So option is B. Higher pressure, lower temperature, greater the density. Because it is MP by RT. Density is directly related to pressure and inversely proportional to temperature. An ideal gas is one which obeys the gas laws under few selected experimental condition, all experimental condition, low pressure and high temperature only. So it is all experimental conditions. Our answer is B, or over a wide range of conditions. The temperature at which real gases obey the ideal gas laws over a wide range of pressure, that temperature is called Boyle's temperature. Students at times little bit confused with boiling point, Boyle's temperature. Boyle's temperature is nothing to do with boiling point. Rather, Boyle's temperature is the temperature at which the real gases obey the ideal gas laws, but over a wide range of pressure, not only at that pressure. Then it is called Boyle's temperature. Answer is B. Which of the following exhibit the weakest intermolecular forces? There are different types of intermolecular forces: dipole-dipole forces, London force or dispersion force, then dipole-dipole force, dipole-induced dipole force, hydrogen bonding. So many types are there. First one is ammonia, HCl, helium and water. The answer will be helium C, where there is only weak van der Waals force exists. The van der Waals equation reduces to the ideal gas equation. What is van der Waals equation? That is the equation of real gas or deviation from ideal gas equation. So it will become equal to ideal gas equation. Again, the answer will be C, that is low pressure and high temperature. You can find the different pattern of the same question. Low pressure and high temperature is the condition for ideal gas equation, or van der Waals equation reduces to ideal gas equation, or the gas behave ideally at this condition. For all these cases, the condition is low pressure and high temperature, because terms A and B are negligible. Which of the following is a false statement? Gases having same molecular masses diffuse at the same rate. 0.5 liter of nitrogen and 1 liter of helium will have the same number of the atoms at the same temperature and pressure. The value of molar gas constant does not vary with the nature of the gas. And the last one is none is false. First one, Gases having same molecular mass diffuse at the same rate is correct. 0.5 liter of nitrogen and 1 liter of helium will have same number of atoms. So we have to find out here the number of moles. That we can find it out. In both the cases, it will be 4 moles, I think. And we will just calculate and show you. Value of molar gas constant doesn't vary with the nature. So answer is D. See, number of moles of 0.5 liter of nitrogen. 1 divided by 22.4 into 0.5. So it is 0.02 moles multiplied by 2 because nitrogen is diatomic. So 0.04 moles. And moles of atoms of helium is also 0.04. So all the statements are correct. So option D, which is none of the statement, is wrong. Here is the question about assertion and reasoning that I was discussing about you. The pattern is there will be two statements. Assertion is a statement, reason is another statement, and the options are whether these statements are correct or false. First thing, whether assertion is correct, whether reason is correct, whether both are correct and both are false. Then the other thing is whether reason is the correct explanation to the assertion or the first statement. So here we have to be very careful. First we have to find out whether both these statements are correct. After getting that, think about that the second statement is the reason for the first statement or not. First one, the three states of matter are the result of balance between intermolecular forces and thermal energy of the molecules. This is the correct statement I told you in the first about the states of matter. Intermolecular forces tend to keep the molecules together, but thermal energy tries to keep the molecules together, but thermal energy with increase in temperature, it tries to keep them apart. And this is the reason for the states of matter. In which state it will exist, that depends entirely on this. So both A and R are true, and R is the correct explanation of A. So option A is correct. Next one, at constant temperature, PV versus V plot for real gases is not a straight line. PV versus for real gases, because for ideal gas it is a straight line parallel to x-axis, but for real gases it is not a straight line. At high pressure, all gases have Z greater than 1, but at intermediate pressure, most gases have Z less than 1. Z greater than 1 is positive deviation, Z less than 1 is negative deviation. These statements are already given in your textbook, so this is also correct. And because of this, the first statement is dependent on that. So here also the answer is B. Both A and R are true, but R is not the correct explanation of A. R is not the correct explanation of A, because PV versus V, why it is not a straight line, that is not been explained by positive and negative deviation. Next one, the temperature at which vapor pressure of a liquid is equal to the external pressure is called boiling temperature. This is the boiling point, temperature at which vapor pressure is equal to the external pressure, so it is boiling temperature. The reason is, or the other statement is, at high altitude, atmospheric pressure is high. As we go up and up, what happens to atmospheric pressure, whether it is high or low? It decreases. As we go up and up, it decreases. So answer is C. A is true, but R is false. Assertion is true, but reason is false. Next one, gases do not liquefy above their critical temperature even on applying high pressure. Above critical temperature, the molecular speed is high and intermolecular attractions cannot hold the molecules together because they escape because of high speed. Gases do not liquefy, that is correct. above critical temperature because this is the definition for this. Above critical temperature, molecular speed is high because temperature is high, so speed is high. Intermolecular attractions cannot hold, that is also correct. That is why it is unable to liquefy, because liquid means again there will be force of attraction which will try to bring the molecules close to each other. So answer is A. Both A and R are true, and R is the correct explanation of A. One more, at critical temperature, liquid passes into gaseous state imperceptibly and continuously. The density of liquid and gaseous phase is equal to critical temperature. Density of both liquid and gaseous phase is equal at critical temperature because they coexist at critical temperature. There is a graph in your book in which it shows that it remains or they coexist. So both A and R are true, and R is the correct explanation. One more, liquid tends to have maximum number of molecules at their surface. Small liquid drops have spherical shape. This is little bit from your surface tension. So first, liquids tend to have maximum number of molecules at their surface is wrong, but small liquid drops have spherical shape is true. So answer is D. Here is a question of match the column. So this is easy, but to understand or to remember, it will be better. Pressure versus temperature graph at constant molar volume. When the molar volume is constant, such graphs are called isochores. Pressure versus volume at constant temperature, they will be isotherm. Volume versus temperature at constant pressure is isobar. Okay. Match with the gas laws with the equation. It is easy to remember the gas laws from this because you may be asked to derive the gas equation or equation of state or ideal gas equation. So Boyle's law, Charles' law, Dalton's law, Avogadro's law, from matching, if you do time and again, you can remember it better. So the answer here is Boyle's law is PV by T is equal to constant, or P is inversely proportional to volume. Charles' law is volume is directly proportional to temperature at constant, N and P. Then third one, Dalton's law is law of partial pressure. P total is equal to P1 plus P2 plus P3. And fourth one is your Avogadro's law. V is proportional to N at constant T and P. Here is one more matching. Match the graphs with their coordinates. Okay. Because one is a graph given, the other one is coordinates given. PV versus V, P versus V, P versus 1 by V. So you have to, so first one is P, A is third. That is P versus 1 by V. The answer is, and B1 is your third one. 2, C is PV versus V. Which of the following statements is or are true for London force? These forces are always attractive. These forces are important for long distance too. Their magnitude depends on the polarizability of the particle. They are attractive forces, correct. They depend on the polarizability of the particle is correct, but they are not applicable for long distances. The options are 1 and 2, 1 only, 3 only, 1 and 3. So it is 1 and 3. So option is D. They are important only at short distances up to 500 picometer. So this is a question of multiple choice, but here X, Y, or in terms of fill in the gap. Above boil point, real gases show positive deviation and Z values are greater than 1. Below boil temperature, it is negative deviation and less than 1. So here the option is D, positive deviation and greater than 1. So positive deviation and Z values are greater than 1. Induced dipole moment depend upon the dipole moment present in the permanent dipole, polarizability of the electrically neutral molecules. So these are the two conditions given. Induced dipole moment is because of the one is having a permanent dipole, the other one is a non-polar one. So the permanent dipole attracts, as a result of which some amount of polarizability, or it will be creating some polarization. So the option is D, both 1 and 2 are correct. That means dipole moment present in the permanent dipole as well as polarizability of the electrically neutral molecules. Because induced dipole moment depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecule. Molecules of large size can be easily polarized, or high polarizability increases the strength of attractive interactions. So it depends on the size as well as polarizability. The correct value of gas constant, we have done it in a SI unit. Here it is given in liter atmosphere per Kelvin mole. So the answer is D, 0.082 liter atmosphere per Kelvin mole. Per Kelvin mole. Which of the following represent Gay-Lussac's law? Gay-Lussac's law is a relationship between pressure and temperature. The options are 1, 2, 3, 2 and 3, 1 and 3, 1 and 2. But those 1, 2, 3 are relation 1 and 2 both are the relationship between pressure and temperature. First one is P by T is constant. Second is P1 T2 is equal to P2 T1. So both these are correct for Gay-Lussac's law because it is a relationship between pressure and temperature. So option D is correct. Both 1 and 2 are correct. P1 T2 is equal to P2 T1. There are few questions in which fill in the blanks. Force of attraction between two temporary dipoles is known as London force or dispersion force. Temporary dipole, there is no permanent dipole existing. While in motion, it develops some momentarily polarization, as a result of which the opposite charges attract and they have some force of attraction which is known as London force of attraction or dispersion force also. Kelvin scale of temperature is also called. In this chapter, we have introduced a new scale of temperature which is known as Kelvin scale of temperature, and this is applicable in case of Charles' law. We found that in which volume is proportional to temperature but with a fraction of 1 by 273.15, from which this Kelvin scale of temperature is there. So this scale is also known as thermodynamic scale. At STP, molar volume of an ideal gas or a combination of ideal gases. Molar volume of an ideal gas or combination of ideal gases is also an ideal gas. What is the value? It is often asked. 22.71098 liter per mole. Pressure exerted by a saturated water vapor, because this is utilized in our numericals. There is certain pressure exerted by the saturated water vapor present in the gas. If it is collected over water, that is known as your aqueous tension. The deviation from ideal behavior can be measured because real gases deviate from ideal behavior. So that deviation from ideal behavior can be measured in terms of compressibility factor, which is again PV by nRT, or which is symbolized by Z, and that is equal to 1 for ideal gas, and it may be greater than 1 or less than 1 depending on its Boyle's temperature. The lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume, at which they are supposed to occupy, because in the graph itself it has been shown that when it is drawn in the other direction, they are supposed to occupy the zero volume, and that temperature is called as absolute zero. It is not equal to 0, but it is absolute 0, which is equal to minus 273.15. Ideal gas equation is a relation between four variables, and it describes the state of any gas. Those variables are pressure, volume, temperature, and amount of gas. P, V, T, and N. N is the number of moles or amount of gas. So ideal gas equation is a relation between all these variables, and therefore it is also called equation of state. I have tried my best to complete the whole chapter and include most of the questions that are available in this. I hope you will go through the study material again and can prepare your own worksheet to solve these questions, which will be helpful to understand the chapter well, and to do the numericals you can utilize these laws and the equations in a better manner. But for 1 mark questions, most of the questions are included, that is there in our CBSE syllabus. Thank you all for your patient hearing.
Thank you so much, ma'am, for this very useful content, for sharing the useful content with us and sharing your valuable time with us. I am very thankful to say that on behalf of my team and behalf of our viewers, I would like to thank ma'am. For viewers, I had shared feedback form in live comment box so that you fill that form and get your attendance certificate. और मैम को मैं फिर से रिक्वेस्ट करना चाहती हूँ कि मैम फिर से इस चैनल पे आएँ और अपने जो भी मैम का एक्सपीरियंस है, मैम का इतने साल का एक्सपीरियंस है और वो आपके साथ शेयर करें। आई थिंक आज का सेशन बहुत ही यूज़फुल गया होगा क्लास 11th के लिए। जो चैप्टर मैम ने, आई थिंक इसमें सारे 1 मार्क्स के जो भी क्वेश्चंस हैं सब इसमें मैम ने बता दिए हैं और ये पूरा चैप्टर आपका प्रिपेयर हो गया होगा। तो आप ज़्यादा से ज़्यादा चैनल को सब्सक्राइब कर दीजिए, जिससे कि आपको जो भी अपकमिंग वेबिनार्स रहेंगे उनके भी डिटेल्स आपको मिल जाएँगे और जो प्लेलिस्ट में जाके अगर आप देखेंगे तो आपके सब्जेक्ट से रिलेटेड, चैप्टर से रिलेटेड आपको वहाँ पे सेशंस मिल जाएँगे। तो आप उनको देख सकते हैं और अपना रिवीजन कर सकते हैं। तो थैंक यू सो मच मैम अगेन।
Thank you, Priyanka.
थैंक यू सो मच।
Thank you.